What do these symbols mean? So our first, x. X is displacement in meters. Sometimes this is used as an S instead, but WJC use an X. U, initial velocity. By initial we mean whatever the speed is at time equals 0. This is measured in meters per second. V, the final velocity, the speed or velocity when time is the maximum, and this is also in meters per second. A, acceleration in meters per second. And then finally T is time in seconds. Now remember that X, U, V and A are all vectors, which means direction is important, and that we can only use these equations if acceleration is constant throughout the whole thing. Okay, on to deriving our equations then. So first things, let's start off with our definition for acceleration. So acceleration is change in speed divided by time. So change in speed, final minus initial, divided by the time taken to do it. Okay, right, so our first step is we're going to times both sides by t, so we get AT equals TV minus U over t. T's cancel. Next we're going to add U to both sides, so I get U plus AT equals V minus U plus U. They cancel, and that gives me V equals U plus AT. Okay, and this is known as equation 1. This is our most simple XUVAT equation. Okay, second one then. We'll do this on this side. So, our definition for average velocity is displacement divided by the time. Now, if we're finding the average, here we mean the mean, which means we add them up, divide by how many we've got. Well, we've got two velocities. We've got the final, plus we've got the initial. We divide that by 2 because there's 2 of them, equals displacement over time. So our next step here is that we're going to times by t. So we get V plus U over 2 times by t equals x times by t divided by t. The t's on the right hand side cancel, so we get x equals, now normally it's written with the, instead of r divided by 2 at the half, v plus u all times by t, and this is equation number 2. Okay, our next one then. So if this is already v equals u plus at, so let's make this equation go to v equals. So we will first times both sides by 2. So we get 2x equals v plus u times by t. We will then divide by t, so we get 2x upon t equals v plus u. Now we will take away u from both sides, and we get 2x minus u, 2x over t minus u equals v. Okay, now what we're going to do is substitute this into here. So substitute that into there, so we get 2x minus u, only this bit's divided by t, equals u plus at. Okay, now what I will have is 2x, what I'm going to do is add u to both sides, plus u to both sides, so I get 2x upon t equals 2u plus at. Next I'm going to multiply both sides by t, so So I will get 2x equals 2ut plus at squared. Then what I'm going to do is divide by 2, and that will give me x equals ut plus a half at squared, which we'll call equation number 3. Now this, you could see that if instead of having v and trying to organise for v, if we did it for u, what we would get instead is down here is we'd actually have vt minus a half at squared, which we don't see very often. Don't see this one used very often, see this one used a lot more, but it's there for completion. Okay, on to our next equation. So this time we're going to rearrange for t. Okay, so we have v equals u plus a t, and I want to make t here the subject. So first step, take away u from each side. V minus u equals at. Then I'm going to divide by a, so I get v minus u over a equals t. Then we'll do the same for this equation. So we have x equals a half v plus u t. So first step we're going to do is going to multiply both sides by 2. So we get 2x equals v plus u t. Then what I'm going to do is divide by v plus u. So I get 2x over v plus u equals t. Okay, now we make these equal to each other. So I get v minus u over a equals 2x v plus u. Let's try and keep these brackets in for completion. Brackets there. Then going to try and get my v's and u's together. So first thing I'm going to do is multiply by v plus u. So I get v minus u, v plus u, all over a equals 2. Then I'm going to multiply by a. So I'm going to get v minus u, v plus u equals 2a. Then these things here, this is known as the difference of two squares. Very common maths trick, one I suggest you learn because it's going to use very often. So we get v squared minus u squared equals 2a. So then we get v squared equals u squared plus 2a, because what we're going to do is we'll add u squared to both sides. And this is equation number 4. Okay, just to summarise then our 4 XUVAT equations, or 4.5 XUVAT equations. Number 1, v equals u plus a t. Okay, and this one you use if we don't care about displacement. So this is missing displacement. Equation number 2, x equals a half u plus v t. Remember, when it's an addition, doesn't matter which way around they go. So x equals a half u plus vt, and we use this one if we are missing acceleration. And by missing, what I mean is that it's not anywhere in the question, it's not what you asked for, it's not anywhere in the question, not interested in it. Equation number 3, in the order that we did them, x equals a half x equals ut plus a half at squared,
and that's going to be missing final velocity. And then remember, we also had x equals vt minus a half a t squared, and that's if we're missing initial velocity. And then equation number 4, v squared equals u squared plus 2ax, and this then is going to be if we are missing time. Okay, and then that gives us our selection of equations. So remember what I said when I said missing, that means that we don't care about it, it's not in the question, it's not what we're asked for. Okay, hopefully that gives a guide of how to derive them.